3259. 3259. So it draws a little piece of a circuit. It has an inductor, and then a resistor, and it goes from point A to point B. And it says that you have a current flowing through here. When you have a current that is 2 amps and is increasing at a rate of 0.5 amps per second plus 0.5 amps per second, when that happens, then delta V AB is 9 volts, which means you got 9 volts here, 0 volts here. And then it says, if you have the same circuit, and this is some inductance L and this is some resistor R. Same circuit, inductor, resistor, that. If you have a current flowing through that is again 2 amps, but it's going down, right, minus 0.5 amp per second, then the delta V is only 5 volts. So that would be, here's 5, and here's 0. So the question is, and then, what are the values of L and R? Okay. So in both cases, the current is 2 amps. It's just, this is 2 amps increasing, this is 2 amps decreasing. So we know that that's going to make the inductors behave differently. That means the EMF drop across the inductor will be different in the 2 cases, even though they have the same current. The drop across the resistor will be the same, because they have the same current. So the way to do this one is to think back. Remember when we imagined the charge carrier moving around the circuit, and we said that whatever voltage EMF you get from the battery, you had to lose to the elements. So this is sort of acting like a battery, this delta V. Although here there is no battery, it's just telling you the potential difference in this part of a circuit. Still the same idea. So 9 volts in this circuit has to be equal to, what do we lose here? Well, let's see, it's L times di dt. And di dt is 0.5. So really, if we're adding the EMFs on this side of the equation, it would be the normal minus sign. We've brought it over. So it's L times 0.5 is the di dt. And resistance also would be a voltage drop. It would be negative on this side of the equation, but we brought it around. So that is 2 amps, 2 times R. Okay. And then the second one is 5 volts. In this case, it will be negative, because we have the current going down, so it would be a negative sign, and another negative sign, so it would be positive here. In this case, it is negative L times 0.5, the negative there comes out. Plus, it would also be 2 times R. So that's really it. You have 2 equations right there, and you have 2 unknowns, L and R. So you can solve one for L and plug it into the other, or when it's written like this, you can kind of do this cute little trick here of just adding the 2 equations. Then you get 14, and those go away to give you 0 plus 4R. And right away you see that R is 14 over 4, 3.5 ohms. And then you can plug that R into either one of these to get the L. So 9 is 0.5L plus 2 times 3.5 plus 7. Right, so 7 comes over here, makes 2, you divide by 0.5, and you get the L equals 4 henries. That's it.